Have you ever wondered how jingle bells make music? Just think about it. Isn't it fascinating how a tiny bell can fill a room with the most joyful tunes? We hear these delightful sounds every festive season, but have you ever stopped to question how exactly it's possible? Well, we're about to embark on a fascinating journey to uncover the science behind these musical marvels, the jingle bells. So, are you ready to jingle all the way to the realm of sound science? Stay tuned to find out. To understand how jingle bells make music, first, we need to know a bit about the science of sound. So, what exactly is sound? Sound is a type of energy made by vibrations. When any object vibrates, it causes movement in the air particles. These particles bump into the particles close to them, which makes them vibrate too, causing them to bump into more air particles. This movement, called sound waves, keeps going until they run out of energy. If your ears are within range of these vibrations, you hear the sound. When these vibrations reach your ear, they cause your eardrum to vibrate too. This vibration is converted into signals that your brain interprets as sound. Think about when you pluck a guitar string. The string vibrates back and forth, creating sound waves that travel through the air, eventually reaching your ear. That's why you hear the sound. But what about sounds that are far away? Well, sound can travel. It moves in waves and can travel through not only air, but through liquids and solids too. That's why you can hear music from another room or sounds underwater. So, to sum it up, sound is a form of energy that our ears can pick up because of the vibrations it creates in the air or other medium. And these vibrations are caused by anything that moves or changes shape rapidly. So, sound is all about vibrations, but how does this relate to our jingle bells? Bells, including our festive jingle bells, make sound through vibrations. Now, let's dive a little deeper. The shape and material of a bell determine how it vibrates and the kind of sound it makes. You see, a bell is a resonator. It's designed to amplify certain frequencies of sound, much like a guitar or a violin. The round shape of a bell helps it resonate or vibrate at a particular frequency, creating a rich, clear tone. But it's not just the shape. The material of the bell also plays a crucial role. Different materials create different sounds. For instance, a brass bell will have a different sound than a bell made of steel or glass. That's because each material has its own unique properties, affecting how it vibrates when struck. Now, how does striking a bell create sound? Well, when you strike a bell, you're basically giving it energy. This energy causes the bell to vibrate. These vibrations move through the air as sound waves, which our ears pick up and our brains interpret as sound. So, the beautiful jingling you hear from a jingle bell is actually a symphony of vibrations. Isn't it fascinating how a simple strike can create such beautiful music, but how can we prove it? Now, prepare for a simple experiment that will demonstrate how bells make sound. Just imagine, we're going to create our very own Jingle Bell Symphony right here at home. All you need is a bell. Any bell will do. But a jingle bell is perfect for the season. You'll also need a few common household items: a balloon, some rice, and a flat surface. First, let's observe the bell. When you ring it, what happens? You hear a sound, right? That's because the clapper inside the bell is striking the bell's inner surface, causing it to vibrate. These vibrations travel through the air as sound waves, reaching your ears, and voila! You hear the jingle of the bell. Now, let's see these vibrations in action. Place the balloon on a flat surface and sprinkle some rice on top of it. Then, strike the bell and bring it close to the balloon. Don't let it touch though. What do you see? The rice starts to dance, doesn't it? That's because the sound waves from the bell are causing the balloon's surface to vibrate, making the rice move. This is a fun and simple way to reveal the hidden world of sound. The bell's vibrations, invisible to the naked eye, become visible through their effect on the rice. It's almost like magic, but it's science. If you want to have more fun with this, try different types of bells or even other objects that make noise. Do they make the rice dance differently? Experiment with it and see what you can discover. Remember, sound is all around us in every ring, ding, and jingle. And it all comes down to vibrations. When something vibrates, it moves the air particles around it, creating sound waves that travel to our ears. From the smallest jingle bell to the grandest church bell, This is how we get to enjoy the sweet symphony of sounds. And there you have it, the sweet sound of jingle bells, all thanks to the power of vibrations. So, we've learned quite a bit about the science of jingle bells today. As we journeyed through the magical world of sound, we've discovered that the festive tunes we adore are actually all about vibrations. Remember how we talked about the bells? Each time a bell is struck, it vibrates. These vibrations push and pull on the air around the bell, creating sound waves that travel to your ears. The speed at which these waves travel and the frequency at which they vibrate determine the pitch and volume of the sound we hear. And it's not just about the bells. Different materials and shapes produce different sounds. A larger bell made of brass, for instance, will produce a deeper, louder sound compared to a smaller bell made of tin. The shape of the bell also plays a role in the sound it produces. The unique shape of a jingle bell allows it to produce that distinct, joyful ring we associate with the holiday season. The science of sound is everywhere, even in the cheerful jingle of holiday bells. It's a symphony of physics, materials, and design all working together to create the sounds that bring joy to our ears. So next time you hear the jingle bells ring, remember the amazing science behind that joyful sound. Happy holidays, everyone!